Hello, Honors Algebra students. Mr. Lawrence here, and we are going to learn a new technique for solving quadratics. This is kind of crazy. Whoever came up with this was brilliant. I wish I were him. Anyway, here we go. First, before we actually learn the technique, I want to see if you can fill in the blanks on numbers 1, 2, 3, and 4 such that the trinomial you'll create will be a perfect square trinomial. Okay? See if you can do that. Take a minute, see if you can fill in the blanks on 1, 2, 3, and 4 so that you'll be creating a trinomial, and that trinomial will be a perfect square trinomial. This is really ugly over here. I'm going to rewrite that plus sign. There we go. Okay? All right, well, here come the answers. This one should be 16. This one should be 36. This one here should be 49/4. And this one here should be 121/4. Are you wondering how I did that so quick? I mean, some of you were so intuitive. You knew this 16 was here. But I don't know if you realize this. If you take 1/2 of b and then you square it, you get that. Yeah, half of 8 is 4 and then squared. I don't know why it says negative 1/2. Sorry. So you can take the b divided by 2 and then square it. Right? So 12 divided by 2 is 6. Squared is 36. So that makes this really easy. Watch. Half of b is 7/2. Squared 49/4. Bam! Half of b is 11/2. Squared 121/4. We're going to use this. Watch how we use this. This is pretty crazy. Okay. Now normally, for a quadratic, we want it to equal 0. There are some exceptions to that. One of the exceptions is when we complete the square. We don't want it to be equal to 0 necessarily because we need this trinomial to be a perfect square trinomial. It's not, is it? No. So I'll tell you what I'm going to do. I'm going to get rid of that 4 by adding 4 to each side. And then I'm going to do it like those little warm-up problems. Only thing is, since I have an equation, if I do it to the left-hand side, I have to do it to the right. So if I take half of 8 and square it, I'm going to get 16. And I have to put a 16 over here. Okay? So now I have this perfect square trinomial. Well, it's going to factor like this. And I'm always going to leave it as a quantity squared. I'm never going to write the two quantities for this technique. Of course, on the right-hand side, I have a 20. Now, how do you suppose I could get rid of a square? Well, I could take the square root. But if I do it to one side, I have to do it to the other. And so now I have x minus 4 on the left-hand side. I have plus or minus rad 20. That rad 20 is going to need to be simplified. Remember doing that? Yeah, let me get a over here. Rad 20 could be thought of as rad 4 times rad 5. And rad 4 is 2 rad 5, right? You with me? You remember that? Dusting off the cobwebs? So, I'm going to rewrite that plus or minus rad 20 as plus or minus 2 rad 5. Now, x isn't alone, so I'll add 4 to each side. And when I do that, I'm going to get x is equal to 4 plus or minus 2 rad 5. And there are your two solutions. Isn't that crazy? It's so brilliant. It's so simple. I never would have come up with that on my own, but it's just genius. All right. Now, on 6, we don't have a trinomial over there, so we can just put our x squared minus 10x plus the blank like we did in the beginning problem, but then we still have to add a blank to the right-hand side. Okay, so I'm going to take half of 10 and square it. It's going to be 25. Half of 10 squared, well, 25 over here. And so now I have x squared minus, I might as well just factor it. Why rewrite it again? Sorry. Pardon me, I'm going to sneeze. Sorry about that. Okay, so I'm going to factor it as x minus 5 quantity squared, perfect square trinomial, and this is going to be 48. I'm going to take the square root of each side, right? 48 is not a perfect square. So I'm going to get x minus 5. And if I break down rad 48, I'm thinking 16 and 3, so it's going to be plus or minus 4 rad 3. And then I'll add 5 to each side. And when I do that, I'm going to get x equals 5 plus or minus 4 rad 3. And there you go. All right. Tell you what, why don't you try... Oh, no, you better not. I better not turn you loose on these yet. I don't know if you noticed this, but A has to be 1 for this to work. So with 7 and 8, I have some division to do. I'm going to divide through by 2. Right? And when I do that, I'm going to get x squared minus 5 halves x. And I'm just going to take a little shortcut. Subtract 1/2 from both sides. Okay, so I can do my plus blank and my plus blank right there. Okay, now I need half of 5 halves. Well, wouldn't that be 5/4? Right? And just watch what's going to happen here. I'm just going to kind of put that off to the side, 5/4. And when I square that, I'm going to get 25/16. And I get 25/16 to both sides. Now watch how this is going to factor. This is really cool. Some of you are so intimidated by the fractions, there's no need to be. Guess what number is going to go here? Yep, the 5/4. Yes, it will. I promise you. I promise you. If you don't believe me, double distribute. You know, do x minus 5/4 in one quantity times x minus 5/4 in the other quantity. And you're going to get x squared minus 5 halves x plus 25/16. Okay, now over here, I don't want to use negative 1/2. I'd rather use negative 8/16. Why? Because I have a common denominator, like terms. So that's going to become 17/16. Okay. Going to take the square root of each side, yes? And when I take the square root of each side, I'm going to get x minus 5/4 equals plus or minus square root of 17. Well, here I'll do it the long way. I won't skip a step because I'm not there for you to see it. I'm going to do this the long way. I'll draw it out a little bit. I don't want to do it this way, but for you I will. Alright, just taking a bunch of baby steps here. So this is the same as the square root of 17 over the square root of 16. But the square root of 16 is just 4. So what we really have is x minus 5/4 equals plus or minus square root of 17 over 4. Yeah, I could have gone to that way back here. Way back here I could have gone to it, but I didn't. Alright, so now I'm going to add 5/4 to both sides. And I'm going to get x equals 5 plus or minus the square root of 17 over 4. And there you go. Looks like a quadratic formula answer, doesn't it? Yeah, exactly. It's called completing the square. All right. I'm going to get rid of some of my work here so it doesn't get in the way of my other problem, but you can always back it up. Okay. So again, on this one, I have to get rid of the 3. It has to be a 1 for this technique to work. I'm not sure why. Divide all the terms, and when I do so, I'm going to get x squared minus 7/3 x, and I'm just going to put up plus 1 over there. Yeah, it's a minus 1, and I added 1 to each side. Okay, so I've got plus a blank, and what's going in that blank? Well, I need half of 7/3. Well, that would be 7/6. Square that is going to be 49/36. And that would be 49/36. So that's going to be 36/36, right? Because I want that common denominator. Okay, going to factor. Going to get x minus 7/6 squared. How did I do that so fast? It's just this number. Just half of that. That's the one that goes there. Okay. And let's see. 36 and 49 is 85. 36. You notice my denominator is a perfect square again. Yeah. Okay, going to take the square root. Take the square root. And I'm going to do this one a little faster. I'm not going to show all the baby steps. If you want to come in office hours and say, hey, can we do a couple? Maybe send me an email, heads up. I'm going to get x minus 7/6. That's going to equal plus or minus square root of 85 over 6, right? I don't think 85 is going to break down. I want to say 17 times 5, and there's no perfect square factors hiding in there. Yeah, you can check that, but I don't think so. Then I'm going to add 7/6 to each side, and I'm going to get x equals 7 plus or minus the square root of 85, and that's all over 6. And bam, I am done, and I feel so blasted intelligent because I'm such a math geek. This stuff is so cool. All right, I hope you guys are doing great. I really miss teaching you guys. That's it for the video. Please come see me in my office hours. Hey, have a great weekend, and if you celebrate Easter, happy Easter. Bye-bye.